you. I hope everyone is okay. And today we will start our section number 8, which is electricity, right? And we will start from very basics. And this is our lecture number 26. So let's start the proceedings, right? Now, the first question which comes in anyone's mind is what is meant by electricity. So basically, what electricity is all about. So electricity is all about charges. Now, what exactly it is meant by, right? Scientists believe that there is a theory that any substance which is existed, it has positive charges and negative charges, and both are equal. When both charges are equal, it means all the matter which is existed in this universe, in this world, is in neutral. Why neutral? Because positive and negative charges are equal in number. Now, if electron is being gained, it converts into ion. If electron is gained, then it becomes a negative ion. And when electron is lost, it becomes positive. So technically speaking, it's all about moving of a negative charge or coming of the negative charge, right? So technically speaking, we are talking about the negative charge here, right? So electricity is all meant as the movement of charges. In this electricity, one of the definitions from where we will start it is current. What is current? Current is a rate of change of or rate of flow of, not change of, rate of flow of charges. So rate of flow of charges is called as current. So flow of charge over time is called as current. Flow of charges unit is coulombs, right? And time is seconds. So coulombs per second is current unit, but the SI unit will be ampere. Because the scientist who discovered it, his name was Ampere. So unit is ampere. Why they say flow of charges? Because the flow of charges can be negative, right? So it means that there are two kind of currents we have it. One current is called as conventional current, which is a flow of positive charge, and the second one is called as electronic current, which is a flow of negative charge. Now remember that we always consider the conventional current direction, which means if there is a battery here, we always consider the flow of conventional current, which is from positive to negative. This is the sign convention we take, right? This is what the current is. Next is there is a definition. There are three things which we are discussing at the same time because these three things are same as well as different for the timing. We are considering them same. Voltage, potential difference, and electromotive force. When you say voltage or potential difference, mathematically, what exactly it is equal to? Voltage or potential difference, it is equal to energy supplied, or you can say work done in moving the charge from one point to another within the circuit. Like whatever work done is done by this battery to move the charge from one point to another within the battery, within the circuit is called as voltage. Either you're saying it's an energy that is supplied, or either you're saying it's a work done that is being done to actually, move the charge from one point to another within the circuit. Unit is joules, per coulomb, right? But again, the scientist who discovered it, his name was volts. So the SI unit for voltage is volts. There is another name which is written here, electromotive force. Now, as the name suggests, electro means electron, motive means motion. So, what is that definition? It's a pumping force. It's a pumping force that pumps charges, or in this case, that pumps electrons from one point to another. It's the same thing as the water pumps the, water tank, or you can say water pump pumps the water with the pressure. Same thing, that battery pumps the charges with more pressure, right? More voltage means more pressure means more value of current it can pump into. So this is the definition of voltage, potential difference, and electromotive force. Now there is another small concept which is here, which we call it resistance. Now, what exactly is resistance meant by? When the current is passing through any particular wire, conductor, or anything, it faces some resistance due to its particles within that. That particles may allow some amount of current to pass through or may not allow the particles to pass through. That opposition offered to the flow of current is called as resistance. Its SI unit is ohms, right? This is the unit. Now, resistance is more or less, it depends on the material. There are three kinds of material: conductors, insulators, semiconductors. Now we are talking about conductors, so they must be electric conductors, an electric insulator, because we are talking about electric. So conductors which conduct electricity, so they will you can say show less resistance to the current. Insulator, like rubber, wood, they definitely show more resistance to the current. And semiconductors, they depend on the temperature. They do behave as conductors sometime, and they do behave as an insulator depending upon the temperature values. So this is what the resistance of all about is. Now, the very next topic in this case is, we called it Ohm's law. Now, what exactly is Ohm's law? Ohm's law is saying that voltage or potential difference applied is directly proportional to the current passing through the conductor, provided all the physical conditions remain unchanged. So V is directly proportional to I. When you reduce that directly proportional, there is a constant coming up, and we called it R. So the formula is V is equal to IR. Now this R we already discussed. This is a radius. This is the resistance. Now what exactly it means is, voltage is directly proportional to current, provided all the physical conditions remain unchanged. The point is, what do you mean by physical condition? Physical condition means temperature. Why? For example, let's talk about a conductor or a simple wire. We do call it ohmic. Uh, we do call it ohmic load because it obeys Ohm's law. Now, once the current passing through that, what will happen? When the current passing through, right, the temperature start rising, as we know that. So temperature rises. As the temperature rises, what will happen? The particles within the conductor, they vibrate more vigorously and they collide with each other as well as with the current which is coming in, right? Now, when they collide more frequently, the chances they collide with the electrons, or you can say current, will increase, which means resistance will no longer be a constant quantity, but it will also increase. So once the temperature rises, the resistance of the conductor also increases. This rule is when voltage is directly proportional to I. At that point, the resistance must be kept constant. That is the reason this physical condition is represented as a temperature. So temperature means if the temperature changes, then voltage will no longer be directly proportional to the current because resistance is also changes. So voltage is directly proportional to the current at constant resistance and at a specific temperature. That is what the physical condition means. Now, graph of a voltage and a current is like that. It should be a straight line, which is showing the direct relationship of voltage and a current. Now, very important. You can find that resistance. How? Find the gradient. The gradient will be I upon V in that case, right? Now, we know that V is equal to IR. So, R is equal to V upon I. So, technically speaking, in that case, when you find the gradient, which is Y upon X, which is I upon V, it is equal to 1 upon R. So you have to reverse 1 upon R value to get the resistance of a particular wire. So remember that if voltage is on x-axis and current is on y-axis, the resistance of that wire or a conductor can be found out by simply reversing the gradient of the wire, gradient of the graph. And if current is on x-axis and voltage is on y-axis, and you want to find out the resistance, simply find out the gradient, which is V upon I, and you will get the resistance of the wire, right? Now, another very interesting point. What if you will have a graph like that, which is straight, but after some time it shows a curve, same voltage and current. You can say though, for example, till here, the temperature was constant, but as soon as the temperature varies, voltage will no longer be directly proportional, and it shows you a curve value. This curve means voltage is no longer directly proportional to the current, and resistance is no longer constant, but it varies as well, or it changes as well. That's what it means. Now, once you understand that, now there are other factors as well. There are other factors as well at which the resistance of a wire or a conductor varies. What are the factors affecting resistance? Number one, length of a wire. When you say length of a wire, we know that resistance is directly proportional to the length. If length increases, resistance definitely increases. Secondly, area of cross section. Definitely, we know that it's inversely proportional. If area increases, resistance will be less because more chances, more current will be flowing through. And if the area is smaller, resistance will be more. If you make this thing a single proportional, then they become a formula. R is equal to rho L upon A, where this rho is called as the resistivity constant. Now, what is that resistivity constant? If you find the value for that, it will be Ra upon L. So resistance is ohms, area is meter square, length is meter. So you can say the unit comes as ohm meter. So area, simple resistance is ohms, but ohm meter is a resistance of a certain piece of wire. Remember that resistance can vary as definitely the length increases. Excuse me, the resistance increases, but for a particular piece of length, the resistance for any particular thing, any particular wire is constant, right? So this is what the resistivity is. Now there are a few more things. What is meant by circuit? I'm keep saying it circuit, circuit, circuit. So circuit, it's a closed path, right? Which comprises of what? It comprises of safety equipments. When you say safety equipment, it means fuse, you know, and you can say circuit breakers. Then you have wires or conductors, electric appliances. Normally, we consider it as a resistors, measuring devices. Normally, we consider it as a voltmeter, which is used to measure the voltage, or ammeter, and that's it. So these are the so important thing is it's a closed path. If it's an open path, it cannot be a circuit. It's a closed path that consists of these equipments. Now, all these equipments which are there, they have their symbols, electric symbols. Like this symbol, whenever you draw a circuit, this is a symbol for resistance. This is a symbol for variable resistance, which varies. This is a diode. Motor, ammeter, voltmeter, bulb, LDR, light dependent resistor or resistance, whatever. Then you have LED, light emitting diode, which emits light. Switch, electric switch. This is called a closed switch, and the other position was the open switch. Then you have a battery, which is that side, battery. Now, these things, power device is also a part of that, which I missed, which is called battery. So these are the symbols of a circuit. Now I'll draw one circuit for you. And that circuit is saying one resistance, one power supply, and that's it. This is a circuit which consists of one resistance and one power supply, right? So this is what we called as circuit. Now, one thing very, very interesting at that point, which we can discuss, is how many types of circuits do we have? How many type of, first of all, you can say how many types of circuits we have it. We go now. If you if you talk about the how many types of circuit we have it, then we can say it's AC circuits or supply. You can say it's mostly a supply actually, or a DC supply. When you say AC supply, AC means alternating supply. Or alternating current. In that case, the supply is like that. It increases, it reduces. So current or voltage value keeps on changing. The value is changing as well, or magnitude, plus the direction also changes. In case of DC, it's direct, straight line, doesn't change. So value remains same, no direction changes, and direction keeps on changing. Direction will be same as well. And when you say what is DC circuit, there are two: series and parallel, right? One thing which actually we missed it, the formulas which we have it. V is equal to IR. It's a voltage and a current relationship. Now, we already discussed what power is. Now, let's quickly see what electric power is. Electric power unit is watts. We already discussed that. But here, electric power got three formulas: VI, voltage into current, I square R, or V square. The unit is watts. So we have series circuit and parallel circuit. So students, we will finish the class at this point. In the next class, we will discuss the series and parallel circuit and their questions related. Okay. Hope to see you in the next class, which is 27th lecture. Thank you. Thank you for watching. Bye.